A manufacturer produces pain-relieving tablets. Each tablet is in the shape of a solid cylinder with base radius x and height h as shown in figure 3. Given that the volume of each tablet has to be 60 millimeters cubed, express h in terms of x. Show that the surface area a millimeter squared of a tablet is given by a equals 2 pi x squared plus 120 over x. The manufacturer needs to minimize the surface area a millimeter squared of a tablet. Use calculus to find the value of x, for which a is a minimum. Calculate the minimum value of a, giving our answer to the nearest integer. And show that this value of a is a minimum. So there's the question then, lots of parts which are all summarized here. I've drawn the picture with all the information contained therein, here. We'll do part A first of all then. Okay, part A. The volume we're told is 60, so 60 is equal to then, now we've got the volume of a cylinder which is pi r squared times h. Pi r squared is pi x squared times h. And now we need to express h in terms of x, so we can simply write h is equal to, move the pi x squared from times down to divide. I've written it down from right to left. So there we go. H is equal to 60 over pi x squared. Okay, so that's the first thing then. Now B. Show that the area A is 2 pi x squared plus 120 over x. This is the total surface area. So here A is equal to pi r squared, pi x squared there, plus another pi x squared on top, plus this strip here, which you unwrap it, the circumference is 2 pi r, which is 2 pi x. So that would be the length of the whole cylinder if it was unwrapped. 2 pi r is the circumference distance times the height is the area then when it's unwrapped. So it's 2 pi r, which is x, times the height, which is h, and we can put in the h value, can't we? So we get 2 pi x squareds then, which is what we want, and then it's 2 pi x times h, which is 60 over pi x squared, which equals 2 pi x squared then from the first term, and then here we've got 120, and the pi's will cancel, and one of the x's will cancel as well, won't it? So just leaving an x. So there's the surface area then, and that's the formula we've got in millimeters squared. Find x for which a is a minimum. So let's use calculus then to find this, as the question stated. So here, let's get the derivative then, dA dx. 4 pi x then, power rule. This is power minus 1, isn't it? So it's minus 120 x to the minus 2, which we can write like so. Let that equal 0. That implies that 4 pi x, move this over the equals, 120 over x squared. So that tells us then, move the x squared up to give x cubed, equals, leave the 120 as is, and move the 4 pi down below the 120 at the same time. So that tells us x cubed. 4 goes into 120 30 times, so it's 30 over pi. Cube root, x is equal to the cube root of 30 over pi. Calculate the minimum value of a to the nearest millimeter. So this is the x value, and we now need to put it back in. Show that this value is a minimum. What I really need to do, find x for which a is a minimum. So we need to get d2a by dx squared, really, don't we, to show it's a minimum. So d2a by dx squared then. Here's the ADX, just differentiate this again. It's going to be 4 pi minus, the 2 comes down, minus 2 comes up, so it makes it a plus. 2 lots of 120 is 240 over x cubed, which equals, now if we put the value in, when x cubed is 30 over pi, we get 4 pi plus 240 over x cubed, which is 30 over pi. So the 30 over pi, the pi can swing up to the top. 30 goes into 240 8 times, so 8 pi plus 4 pi is 12 pi, which is positive when x equals the cube root of 30 over pi, so a min, because the second derivative so it's positive, so it's a min. Okay, that's part C done then, and we've shown it's a minimum. We found the value of x. Calculate the minimum value of a to the nearest millimeter squared. So the d then, so a is equal to, okay, so it will be 2 pi x squared, so it's 2 pi times x squared, which is this power third, so it's 30 over pi to the power third is what we've got, and then we square it, don't we? So this whole thing squared, power u times, so 2 times a third is 2/3, plus, so that was the 2 pi x squared, plus 120 over x. Now it's a cube root of this, so we can keep it in one block if we wish, of 30 over pi, because it's only a calculation anyways. Okay, let's tap it in the calculator then. So it's 2 pi then, 2 times pi, times, bracket, 30 over pi, close bracket, power 2/3 2 divided by 3, jump out of the power, plus 120 divided by bracket, the cube root of 30 over pi, so I need another bracket, and it's 30 over pi, shift pi, bracket, power third, wasn't it, because it was the cube root, and then come down to ground level and close that bracket, and then press equals. 84.8 to 1 dp, which is I think what the question asked for. 84.8 to 1 dp, 84.8 millimeters squared, and that was to 1 decimal place. Let's just check that then for part D. To the nearest millimeter, so that equals 85 millimeters squared, and that's to the nearest millimeter. Okay, good. So that's the surface area then, and show that this value is a minimum. Okay, well, I think we demonstrated the minimum value of a, for which a is a minimum here, because the second derivative was negative. So that should suffice there. So this was part E here. We verified it was a minimum. We did that because it was implicit in a sense, for when it said find x for which a is a minimum. So we did the calculus there.